Hey everyone, how's it going? In this short video, we're going to talk a little bit about force and interactions. And I'm going to ask you to take a couple of notes while we're talking about this. Okay? Interactions are really important. For the first couple of units in the class, what we've been really talking about are the descriptions of motion. So, whether things are accelerating or standing still or how their position is changing, and the fancy term for this is kinematics. But now, what we're going to be looking at are the causes of motion. And that falls under the realm of what we call dynamics. So kinematics is describing motion, dynamics is the cause. And in order to keep track of things, we set up what we call an interaction diagram. Now, an interaction diagram basically tells us all the things that are interacting with everything else. Okay? So if you imagine that you had a book that was just sitting on a table, what would be the different things that could interact? Well, of course, at the center, we're going to be focusing on the book. And because the book is affected by gravity, we would put the Earth into this interaction diagram, and we would put whatever the book is sitting on. Let's say it's sitting on my front table. And those things interact with the book. Now, there's lots of other things that could interact with the book. You could think about the air surrounding it, or you could think about people in section 1 down the hall in Dr. Weiner's room. Or we could think about things further away, maybe the sun or the moon. And we could think about even things that we can see indirectly, like, for example, light. Okay? Light hits the book, bounces off of it, comes to our eyes. We could even talk about things like the floor. So, in order to identify what interacts with an object, you would want to ask the question, if you remove something from this diagram, would the book do anything different? And the answer for most of these is no. So for example, if we took all the air out of the room, the book would still be sitting on the table. If we got rid of all the people in section 1, made them go home, something like that, that would be nice. That doesn't affect the book on the table. If we got rid of the table, then that would be a problem because then the book would be falling. So that's why we can't get rid of the table. The sun and the moon, although they do affect the book, the amount is really small. If I turn off the lights in the room, that doesn't affect the motion of the book. And this is the tricky one. Specifically, if I get rid of the floor is going to affect the table, but the floor isn't directly touching the book. So in this interaction diagram, we want to ask the question, if we remove something, would the book do anything different? So that's why I can get rid of this link here. And so the only two things affecting the book are the table and the Earth. So now let's talk about the types of interactions. And there's two basic types of interactions. The first are what we call contact forces. Contact forces come in a couple of different varieties. One of these is called the normal force. And the normal force is a force between two surfaces. So it's at a boundary, and it acts perpendicular to the boundary between the two surfaces. So for example, if I have my book that's sitting on my table, the normal force will be pushing up because the boundary is horizontal. So normal is a math term that means perpendicular. Okay, let me get rid of this. Another type of contact force that's really important is friction. Now friction is similar to the normal force in that it acts between two surfaces, but it's parallel to the boundary. So if I have a book that is sliding across the table, we'll label that a v for its velocity. Friction would be sort of going opposite of that. Friction is a force, velocity is not, but we'll talk more about that in a moment. Okay, and then we can also talk about tension, which is a force that exists in ropes, chains, strings, etc., and that usually points away from objects. So it points away from stuff. We'll see how that works. That's the first major type of force, is the contact force. The second major type of force is non-contact, and this is sometimes also called action at a distance. And occasionally we even call this by the fancy title of field forces. That's the actual name for these things. They're field forces. What are examples of field forces? Well, gravity, the electric and magnetic forces exist because of a field. And then there's things like the weak and the strong nuclear force. Those are both field forces. Okay, so now we're going to draw this interaction diagram a bit more accurately, and we're going to say basically who's affecting who very specifically. And this is kind of what's in your packet. We're going to write the force, we're going to write the type of the force, we're going to write what that force is acting on and where that force is coming from. So in your packet it says the force on the feeler by the dealer. So who is experiencing the force is the feeler, and who is causing the force is the dealer. Okay, so for example, we can take our book again and we can focus exclusively on the earth and the table. Okay, and anytime you have an interaction, that really means that you have a pair of forces. So a pair of forces is another way to talk about an interaction. Okay, so that means that there's a force between the book and the earth, and there's a force between the earth and the book. There is a force between the table and the book, and a force between the book and the table. And so the way that we write this is, for example, the force between the book and the earth is the force of gravity. Okay? And that is acting on the book by the earth. And we might shorten that so the arrow indicates what the force is acting on. In this case, this arrow right here is acting on the book. So we could call this FG, book, earth, which means that the pair over here is the force of gravity on the earth by the book. So that's this one, and that's this one. That's a pair of forces. Notice that the last two things, the B and the E, get switched. Okay, so this is a full interaction. Also, notice that these interaction forces act on different objects. One acts on the book and one acts on the earth. Likewise with the table and the book, this is the force. Wait a second, what kind of force is acting between the book and the table? Well, that's a contact force. That is the normal force, and this one is actually on the table by the book. So this one would be the normal force on the book by the table. Okay, and so this is a way of organizing all of the different types of interactions. So you need two things to have an interaction. An interaction is made of a pair of forces, and those forces act on different objects. Now the last thing we're going to talk about is a force diagram. This is when we focus on one object specifically. So sometimes a force diagram is called an isolation, or you might also hear me say a free body diagram. And all that really means is that we're taking an object like the book and we are only considering the forces acting on the book. And remember, in your reading in the packet, there's the table, there's the book. We're supposed to do a dotted line around it and consider all the forces that act inside of that box, okay? And in this case, we have two. We have the force of gravity and we have the normal force. So what we want to do, just like in your packet, is set up a coordinate axis. So this is x and y. And we want to write that this is the force of gravity on the book by the Earth. Therefore, this one is the normal force on the book by the table. Notice that these two forces appear in our diagram here. Okay, so that's this guy acting on the book and this guy acting on the book. So we have isolated just the arrows that are pointing towards the book. That's one way to think about this. Okay, now for any forces that are equal in magnitude, we can indicate that with a little tick mark. And we can say that at rest, the force of the table on the book is equal to the force of the Earth on the book. Okay, so the Earth is pulling down and the table is pushing up. Now this is something that we sometimes call equilibrium, but this is also the whole concept of balanced forces. And so there are two different conditions that allow for us to have balanced forces. One is like when the book is just sitting there, that the velocity is 0. But you could also be moving with a constant speed and also have what we call balanced forces. It's just impossible to be moving at a constant speed and only have one force acting. So we'll think about why that's the case, and we'll work with this as we go through. So now we're going to look at worksheet 1A. You're going to jigsaw this, and I'm going to let you guys, actually the sub is going to assign your jigsaw groups, so try and do that to the best of your ability. Okay, so I'm going to stop here, and I will catch up with you guys next time and we'll talk about this.